So cast your mind back to the days when we were first learning calculus, the good old days of the end of year 11. And we sort of thought, okay, if I've got this curvy function here, how can I talk about its slope? Because it's kind of like flat there, and then it's increasing, and then up here it's getting like really steep, so the slope's changing, and it was like, ew, talking about the slope is weird. So we eventually said we're gonna, if we wanted the slope here, we would make a chord there, and we would eventually, like, this distance here we were going to call h, and we we're going to make h really small, and so eventually that chord would get shorter and shorter. So like the next chord, instead of being up there, might only be to there or something, and then the slope of that blue line is very close to the slope of the black line. So that's sort of how we came up with derivatives. And we had a good geometric intuition for what the derivative, how we could find it out geometrically. What we were doing is, if we wanted the slope there, we were drawing something called a tangent to the curve, which is just like a straight line that just barely touches the curve. Just touches it and then goes off. And then the slope at this point here in the blue is exactly the slope of that red line, which is the tangent. And because the red line is straight, it means we could measure the slope. So that geometrically is, the red line is what we call a tangent, and we use it to measure the slope of a curvy black line. So if we know stuff about derivatives, we can actually calculate the equation of a tangent. This red line, the tangent, is just a straight line, so it's going to have an equation like y equals mx plus c, and we're going to figure that out. So let's do that. We got a formula straight for it. So y equals f of x, the equation of the tangent is this. Y equals f dash of a bracket x minus a plus f of a. So let f of x equal that. Find the equation of the tangent at x equals 1. So let's just do that. So a equals 1 in this case, because we're trying to find the equation at x equals a. So in this formula that we're using above here, a equals 1. F dash of x equals the derivative of this, so that's going to be 3x squared, take 2x. And then f dash of 1, we're going to need as well, equals 3 times 1 squared, take 2 times 1, which is 1. And then f of a we also need, so f of 1, without the derivative, so without the dash, is going to be 1 cubed take, so we're basing it off of f of x, which is this, 1 cubed take 1 squared plus 2. Or in other words, 2. So now we've got all of our bits for this equation. So y equals, so it was f dash of a, which was 1. And then the next bit in the equation is x minus a, so that's going to be x minus 1 plus, and then the next bit in the equation was f of a, so that's going to be 2. So this is going to be x minus 1 plus 2, or in other words, x plus 1. So let's check out the graph. There's our graph. And if I graph the line y equals x plus 1, you should see that that's a tangent to the curve. It hits the curve at 1, 2, and it's tangent. So it just barely goes through that. It never cuts through it. It only just touches the red line at that point. Yeah, so cool. That green line is a tangent. And if we look at that slope of that green line, you can tell the slope is 1, because every time I go across 1, I'm going up 1. And we know the derivative at that point is 1 as well. So that's your slope, which is really good. So the equation of the tangent is y equals x plus 1. Occasionally you'll get this other part of the question, like a part B, and it'll say find where the tangent meets the curve again. It's a very common part B for SACE to ask you. So we know y equals x plus 1, and we know f of x equals x cubed take x squared plus 2. And if I want to find out where these two equations meet, I'll just sub it in. So y and f of x are basically like the same thing. So I'd have x plus 1 over here equals x cubed take x squared plus 2. You could rearrange this to get x cubed take x squared take x plus 1 equals 0. Now we're not going to be able to solve that, but theoretically we could to get a value of x. And I reckon actually, no, we can probably just see it here. Well, x is 1, that works. And where is this tangent actually going to meet the curve again? It's going to meet at -1. So let's just check if that works. -1 cubed take -1 squared take -1 plus 1 equals -1 take 1 plus 1 plus 1 does equal 0. So this meets again at x equals -1, or in other words, if x equals -1, then y would be 0. So it meets again at -1, 0. It's a very, very common follow-up question for them to ask you. But the main point of the video is the equation of the tangent. So you're applying that formula. You'll need a, which is the x value. You'll need f dash of a, which you work out from the derivative. And you'll need f of a, which you work out from the function. Or sometimes, like in these questions, you're given it, like in this one here, a is going to be -1 because that's your x value, and f of a is going to be 2, and then you just need to work out the derivative and sub in -1 to get f dash of a.